Assalamualaikum and hi everyone. Welcome back to integration. Now we are at 1.4 definite integral. So now we are going to learn how to uh, integrate definite integrals, because before what we learned was solving integrals with without any borders, any boundaries. So now we are going to integrate integrals with boundaries, namely b and a. So for example, if we have if we want to integrate x from 1 to 2, okay, so first we get x squared over 2, and since it's definite we no longer have the constant. And then the next thing to do is to substitute the values here. So first we substitute the higher value, the larger value, to replace x, and then we minus the one with the lower value. Okay, so in this case what we do is 2 squared, which is 4 over 2 minus 1 over 2. So we have 2 minus 1 over 2, which is 3 over 2. And then you can refer below for properties of definite integrals. So there are 5 properties of definite integrals. Okay, the first one, the second one, the third one, the fourth, and the fifth. Okay, the first one is pretty straightforward, and the second one is just like taking out the constant. So that means if you have a constant, you don't need to integrate the constant. You can take it out and then multiply it back at the end. And property number 3 is like if c is in the middle of b, that means you can separate the integral into two integrals. So you can integrate from c to a, and then from b to c, where c is in between a and b. And then property number 4, if you integrate something at the same point, which is from a to a, you get 0, because actually definite integral is area that you get. Okay, so that's why it's 0. And then property number 5, the integration from b to a is equal to the negative of the integration from a to b. Okay, now we're gonna solve some definite integrals. Okay, for question 1 here, we're gonna solve something to do with properties of definite integrals. Okay, so if we can what we can see here is the first integral. If we integrate fx from 1 to 3, we get 4. So that means if we refer to the diagram here, that means in between 1 3, we don't know how the graph looks like, and we don't know whether it's above or below the x-axis, but we know that the value that we get, or the actually area that we get, is equal to 4. Okay, and then if we integrate fx from 3 to 8 in this area, okay, we get 12, and for gx between 1 and 3, we get 5. Okay, so we're going to use that value to solve the questions in question 1. So the first one is integrate 5fx from 3 to 1. So that means 5, we take out 5 as the constant, and then we know that the integration of fx from 3 to 1 is 4. So we multiply 5 by 4, we get 20. And then for question B, we use the property, since normally we integrate from 1 to 3, okay, the lower value at the bottom and the higher value at the top. So since it's upside down, it's equal to the negative. Okay, so this is equal to the negative of the integration from um, 1 to 3 of fx dx. So we know that that is equal to 4. Okay, so we get negative 4. And then next we have tan fx from 1 to 3 and minus 3 to 1, which is the upside down of 1 to 3 of gx. So the first one becomes 10 times 4 and then minus so 4gx, so it's the negative of that, okay, and then 5 times 5. Right, so we have 40 plus 25, which is 65. Okay, and then the last one, from 1 to 8 of fx multiplied by 3. So we have 3 times the integration of from 1 to 3 of fx dx plus the integration of fx from 3 to 8. Okay, and then 3 times 4 plus 12, which is 16 times 3 and is equal to 48.